So hello guys, the goal of this project today is to try to detect the direction of a swing with an accelerometer, gyroscope accelerometer, the one we use for Arduino, so that we can control the intensity of the light in the room. And here is our swing. Tulcha, can you just put it up?
So our swing is made of an Arduino, which is connected to a computer that gives the power. And this is the accelerometer and gyroscope that is going to detect the direction of the acceleration in the X and Y and Z axis, as you can see on the documentation over there. And we use the NPU 6050, which is a gyroscope and an accelerometer at the same time. So this is our swing. It swings, and as you can see, the gyroscope is swinging, and this is what we're going to detect and record on the Arduino.
Can you swing it again so that we can see that?
So normally it is swinging in this axis. So normally this is sending data to the Arduino, and that's what we're going to look at on the Arduino monitor. So I'm going to open the Arduino software. And those are the data that we get from the swing. I'm going to clear it again.
And now we will swing it, then graph the data.
And before that, I'm going to run the code.
Okay.
This is the code that we wrote, which is reading the data and then writing it in the serial monitor. So right now it's uploading the code onto the Arduino. So it says that the upload was done.
Now that we uploaded the software, we'll be swinging our swing, and we have to look at the data.
So to look at the data, we open the serial monitor on the Arduino software, and as you can see, it is already streaming all of the acceleration that the gyroscope is receiving. And these are raw data, which is containing the acceleration on the linear acceleration and the angular acceleration. But I'm going to clear it like that, and I'm going to swing this our sensor, and then I'm going to release it. So I'm going to release it right now. And at the same time, the Arduino is recording the acceleration.
Okay.
So I think that's enough. Now that it has recorded all of this data, I'm going to stop recording, and we're going to take this data and going to plot it into an Excel sheet.
Can put the swing down.
Okay, so now that I get the data, I'm going to copy, and I'm going to open an Excel spreadsheet. Like this. I'm going to paste. Yeah, these are the data that we got. And I'm going to label this data.
Mm-hmm. You're actually copying from the previous experiences. This is the same order.
Okay, so now I'm going to explain all of the columns. The first 3 columns are for acceleration, and the last 3 columns are for the gyroscope. As I said at the beginning, it contains the X, Y, and Z acceleration, and the X, Y, and Z angular acceleration. And we are going to now create a chart, a line chart to be precise, so that we can see clearly how is the acceleration changing as we swing the balance. So as you can see already, it's giving the very clear data that the movement is sinusoidal.
And you can see that it's decelerating because of the friction.
Yeah, it's decelerating because of the friction. The energy is lost. That's why it's decelerating. And these are the part that we didn't swing yet. That's why it's at around 0 and 1. And there is some tiny vibration because of my hand is not it's not staying I'm
It
going
could be
to-
much better if we take a swing and we put it freely. The data would be clearer.
And, so we see that the data that we recorded is from the y-axis, and this is the y chart, which is a very clear sinusoidal function. And there is a little bit of x acceleration as well, because the gyroscope was not very. It was not at exactly perpendicular to the direction of balancing direction. That's why we have a little bit of x, and we almost don't have it.
Because the difference in altitude is not that big.
So it was the majority of the movement was x. So if you want to have only y, we need to make it very clear, very precise in terms of orientation.
Thank you so much, Tulutra, for the explanation. Bye-bye.
Bye bye.